Hello everyone. Good evening.
Good evening.
Good evening.
So, is there any reason? I think WhatsApp messages used to all of you get. So, all of you get this today's message, WhatsApp message about the session.
Yes.
Yeah, it was received.
Okay. Okay. So let's wait 1 or 2 minutes more. Then we'll start. Let the people join.
Okay. Yeah.
So let's start the session now. Today is Solidus session, and let me present my screen. We'll solve some problem, which one related to week 9. Uh, I hope my screen is visible to all of you.
Yes, yes.
Okay. So who will get the answer? So while answering, you will just use the chat box of this meet. That would be good. So this is the way we'll forward the session. So, and this is the first question. And in this question, we need to find some constraint. And regarding the constraint, we have information. What will be the constraint equation for the case when you have maximum 3 hours time to solve whole question paper? If it takes 10 minutes to solve MLF problem, 12 minutes to solve, mathematics problem Y, and 5 minutes to uh, answer English question set. Yes, so please will you use the chat box? I hope rest all of your solving, like Raj have just given the answer. Please, if you want solve this problem. I don't know. Okay, I think have solved this. No, nothing. There is no PD code. Okay, so don't worry. We'll see here. The question we'll see on on the this Explorer on a PDF format, and we'll see. Will all of you post here in chat box of this Gmeet. Okay, so if you'll solve this problem here, just a small calculation is that we have to change this, this one to in minute, or we can change this 10-minute, 12-minute, and 5-minute in hour. So we change this one to uh, minute form unit, so it will be 180 minute. Now there are so there are three type of problem: MLF, mathematics, and English question. So I think it will be a kind of one single questions. So here is 10-minute to MLF problem. So that means which is in the variable form x is given. That means we can say 10x time, and then plus 12-minute to solve mathematics, which is y here, 12y, and 5-minute to English, and this is 5 set, and maximum time hour is given. So it could be solved less than or equal to. So this time is maximum is given. So that means 3 hours, or we can change it to minutes. So it will be less than or equal to 180, which is the third option. Is matching with the information whatever we have. Okay, so let's solve the next problem. I hope everyone is got the answer and clear with this explanation.
B is correct, sir. We can also mark as right.
Second one also.
Yes, sir. Because they have given 3 hours, I think.
So, but 3 hour is given. So, if we want to change this in a minute form, then it would be good.
Yes, sir.
So that's why the third option is correct. And the second problem we have, points are given. These points form a convex hull. In last session, we have discussed that what is the convex hull, taking the linear combination with some constraint. Which of the following points are the part of this convex hull? So please, if you can solve this. D. Okay, so let's solve this problem. So we have given some point. If you assume this is x1, this is x2, this is x3, and this is x4. So we know that convex, how we'll form a convex hull. We'll write a lambda1 x1 plus lambda2 x2 plus lambda3 x3 and lambda4 x4, where the constraints are all should be greater or equal to 0, okay? And sum will be equal to 1. So if this is in, we have in the point form, so what it represent? If we see it in geometrically, if we try to see in the coordinate system, the first point x1 will be 0, 0 here. 0, 2 is here, and 2, 0 is here, and 2, 2 will be here, right? And if we observe that, if we form the convex hull, okay, so see that this sum is going to be this one. This is one important thing, that this tells you that the convex hull is going to be this region. Okay. And if we have the forming the convex hull, and which point is belongs to the convex hull, so if you see that all points are someone, at least one coordinate or both coordinates are falling in the negative side. Fourth point, both are actually lying in this set. Somewhere one will be here somewhere.
Sir, graphically solving this is okay.
Yes.
That intuition is okay. If we don't consider the graphical intuition, if we use the expression, how to approach this?
So approach will be as similar to, we have to so this is going to be, so set is going to be convex hull set is going to be this one with these constraints. Now this is the set, and which set, so we'll try to see that which one is following this linear combination. We know which one is forms the linear combination. We have 0, 0, okay, and then 2, 0, 2. So if you assume this lambda1 0, 0 plus lambda2 0, 2 plus this is going to be lambda3 2, 2 plus lambda4 2, 0. So again, if we try to solve, this one is going to be lambda1, okay, plus so lambda1 is going to be 0 here. So we'll get a system, so not a system of linear equation, we'll get a this way. This is going to be lambda3 plus 2 times lambda3 plus 2 times lambda4. This is one, and the second coordinate is going to be lambda2 plus 2 times lambda3 plus yeah, that's all. We'll get to this coordinate. Right. So yes, is going to be this one. But with the constraints are all this lambda I.
So 2 times lambda 2 plus 2 times lambda.
So 4 times will be, yes, here it will be 2, 0. So 4 times lambda, not 4 times lambda.
So 2 times lambda 2 plus
2 times lambda 2. Okay.
Yeah. Now it is okay.
Now it is 2 times lambda 2, and with these constraints, lambda I greater or equal to 0 and sum. So now this is we have, so which point actually, so here this tells you that each are positive, each lambda is positive, and which one, if we assume any, like here is this one, and this is positive.
How did you positive? Already we know it is positive. It is a
Already we know that it is positive. This is the
Right.
constraint we
Okay.
have.
Right.
So which one give the positive one? If we sum them, this one, so this one is positive. This is a product, no? Why it is not working? Okay, just a second. So if we assume, okay, so this sum is should be positive. This sum is positive. Both coordinates should be positive. And which one is tells you that is positive one? Only this one, right?
Yeah. Okay. This is case. There is no other option positive. But if
And
some
suppose there is
corresponding
another thing, that suppose there is a 1 point, if you assume here, let's say outside of this, which is 3, 1. Okay. So in that case, that means this is, we can assume that if we assume this point 3, 1 belongs to this set, okay, then we'll get, so we'll get a system of linear equation, right? If we assume that this is going to be this, and this 2 lambda 2 plus 2 lambda 3 is going to be 1. Now we'll try to solve this system of linear equation, and we'll get some value of, so this system, see that this is with the 4 variable. Okay, with 4 variable we have lambda 1, this is going to be 0 time lambda 1 plus 0 time this is 4, it will be. So here 0 time lambda 4, and then this will form a system of linear equation. This will form a system of linear equation. This have either it have infinitely many solution or it have no solution. So
There are
with
three
this
variables.
constraint, so we can use this constraint also, right? We can use this constraint lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 equal to 1 also.
Right.
So for this one, at least 4 variables and 3 constraints are there. So anyhow we'll get a contradiction. Either could have infinitely many solution or no solution. So maybe we'll solve this one. All of you, please check this one with this, that it have no solution or will getting infinitely. If we are getting infinitely many solution, that means, lambda 1 or any lambda I could be given any real number, and that is also not true. That is not going to be true, because any value are going to give, but here is with the some constant only we are able to give. The sum is going to be this one. So either there is a possibility that this have no solution or it have infinitely many solution. If no solution, then we are wrong. If no solution, then we are doing wrongness. If it have infinitely many solution, then we have to check. So there is a possibility there will be a possibility that 2 or maybe 3 variable have infinitely or independent variable, and in that case you are going to give any value to lambda, and again we'll get a contradiction that okay, it is not going to be from this set. So most probably the chance will be no solution. Please check either, so planes or may not be intersect at a single point. Okay. So by this way, this is one way to solve this. Another way. Okay, let's move.
Solve for 1, 1. Is it possible to solve?
So let's move to the next problem, and then the last we'll try to do it. Okay.
Right. Okay.
So given a S is a convex set and the points are this, which of the following point must be the part of the convex hull formed by these points? So this is not, I'm not doing on, this sphere deck. I'm just solving on, a PDF format. So please write your answer in chat, Gmeet chat. Okay, so this question is also very easy. We just need to use the constraints for the convex hull. So either the positive constraint will, using that you can neglect the option or sum. So if you see that, you try to solve with, with the sum, you may not get one. If you sum these all, you may not get one. So you can check this one. This is going to be 8. These two will sum itself 0.8, and these two sum will more than 1. And here is this one is negative. So this one and this one, these two are not going to be. If you solve this one, this sum is not going to be up to 1 also. So how it could be equal to 1? So, and this one is possibly. You sum them all, it will give 1 and all are positive. And these points are here. So as it is following the definition of convex hull, as the definition have the convex hull. So D option is going to be correct to form. So must be the part of the convex hull formed by these points. This one is very easy. I think the next problem is good. So let's do this problem. Okay. The fourth problem, storage set is to be built in the shape of a box x dot x with a square base. A base is a square, but height may be differ. Okay, and height will assume from our side. Even you can assume h. And the volume of that box is, we are thinking it is going to be 800 cubic meter. The concrete for the base is 50 rupees per square meter. Okay, and the roof for the roof is 70 rupees. Okay, and material for the sides are 60 rupees. What will be the constraint for this equation? We try to solve this one. What constraint will get, and what is the objective function? I'm asking. Here is the two problems, which is fifth problem also. We'll solve two problems simultaneously. So this is the first problem. The second problem is what is the objective function. So if you see, the fifth problem is actually try to find the objective function. So we'll see it. All of you will solve simultaneously both this one, and when I will move to the fifth problem, will just tell me the answer. So this, the constraints one and the objective function.
So we're going to assume the height, right? Height has not been given.
And what is going to be objective function? You can choose from this option. Which option is going to be true for the objective function? All of you have noted the information.
Sir, objective function is option C, sir. Option C, or either we take a the constraint and also, sir, option C, sir.
No, here's why the
constraint
option
should be
C is
option
not. The
B.
reason is it is going to be have to, not up to.
Huh.
It is to have a value, not there is
Okay.
no up to.
It has to be
So
equal
it's
to 800.
it should be D.
So, but we want the volume, just volume, right?
We
This
do
one
not
tells
have a
you
cost
price.
bound.
No, this tells you the price, kind of. So that's the
Okay.
objective function.
So it should be, sir, B H x square is equal.
Here is not up to, it is to have, not up.
So it's a volume, sir. Its answer should be B H x square is equal to 800.
Yeah. So we have the base, area of the base is given, and we are assuming the height. So into
So your
Can you
voice.
show question 5?
and the volume is given.
Can you show question 5?
The first,
So your voice is breaking, sir, not audible.
let me see about my voice is breaking.
Yes, sir.
Okay, now is it better?
Yes, sir.
Yes, sir.
Okay. Okay, so here is constraints is, as the volume is 800 is given, so this is hx square is going to be, okay, what happened, equal to 800, and now objective function, okay, just
So, but where do we have the, like, where do we have that this is going to be equal to the price? We are only saying that 120 into x square plus 60 into x into h, that is going to be the
there is no,
price.
so that's why
But
this
we
is not
cannot
going
say,
to be our constant, no? So this is not going to our constant, where it is, there is
uh,
no constant for the price.
and
So
we
we have
cannot
to find
really
the
find the
objective
objective
function and the
function.
constant.
Okay.
Sorry?
Objective function, I can say that 120 x square plus 60 x h is there, but
Even
if
that
we
is also not. Even how it could be 60 only. We have to check that.
There is no
So
objective function here, right? Only
there is
no,
no
constraint.
there is
objective
no one
function as
is
such.
the objective function.
Hmm,
There is only constraint function here.
Only constraint is given. No? There is no
exactly.
constraint we want to choose. Only the volume is actually constraining here, making a constraint here. So that's why this is going to be constraint. Now objective function we want. So objective function is, I don't know how it could be mean to say I want to minimize or maximize, but the objective is going to be, either the possibility is that we have the price is given, we want to minimize that price. So that is the possible here. So 50 rupees for the, we have the base cost. So base area is, we have x square, okay, and which is going to be 50 here. Okay, and roof cost is 70 rupees, and roof is also going to be same, because as whatever the, we have base and height both are actually with the same. So 70 into x square. Now side is given 60 rupees, and there are 4 sides, will be right. If you have box, it have 4 sides with the some height. So what is going to be area of one side? H
60.
into
X
x.
into H.
Okay, h into x, but it have four sides,
4h's.
so 4 is going to be there. Now price is for that is 60, so that's why it is going to be, so this is going to be 120 x square plus 240 hx. So now if you choose the option here, so C option is going to be correct. Let's do the 6th problem here. Okay.
Done, sir.
Okay, many of you have A, just A. So how this problem could be solved?
So we find through Hessian matrix.
Yes. So
Minima.
this, if you try to solve by this Hessian matrix, we have,
Yes, sir.
a differentiable function. If a function is twice differentiable, and we want to
Yes.
check that function is convex or not, so we'll go with the Hessian. Hessian matrix should be positive definite. And when it will be positive, the eigenvalue should be positive. So here two variables are given. That means what? Just a second. Okay, so here is two variables we have. So convex, that means, sorry, Hessian matrix is going to be, of 2 cross 2. So if you try to find one by one, if you go with the first one, and here is, fx, f suffix x, for partial derivative with respect to x is going to be 4x, and double partial derivative is going to be 4. And now if you try to find f suffix xy is going to be 0, as this is with derivate with respect to y, this is going to be 0. Similarly, this one also either could be xy or yx. It is a polynomial, so it could be commutable here. This one is commutative, so that's why it is going to be 0, or you can find with respect to y then x. And now this is yy, and what we found, this f partial derivative with respect to y is going to be this 10y, and double derivative is going to be 10. So Hessian matrix is 4, and then here is xy, which is 0, yx is going to be 0, and yy, and this is going to be 10. So this is a diagonal matrix, and both are positive. So eigenvalues are actually positive, so this is going to be a positive definite. So this is a convex function. Here is, see that now very clear with this one, the second partial derivative is going to be a constant one, and if you see that it have the negative. So, and also in both cases you will get Hessian matrix, which is a diagonal, which will be a diagonal. So you can see that both will give a kind of negative, So this is not going to be a positive definite. And this one also tells you that here, if you check, this will at least at one diagonal, you will get -2, and somewhere we'll get 4. So Hessian matrix for this one is going to be this, which is not a positive definite. If you check for this one is going to be 6 and -6 and -2. This one Hessian matrix for the second one is going to be this one, and for both here at the diagonal, both are negative, so not going to be a positive definite. So only the first option is going to be a positive definite. Sorry, for the first one function, we are getting the positive definite, so that's why it is going to be a convex function.
So is there any other way to solve this apart from this approach?
There could be, we have general case. This one is the best one. And whenever we have in the multivariable, and the case is differentiable, partial derivative is, we are able to get that. So this is the best one. We can do with this one lambda 1 x1 plus 1 minus, not lambda 1, lambda x1 plus, not here is x1, x just x 1 minus lambda. This should be less than lambda, not even this, sorry, not in this form. This is going to be lambda x1 y1 plus 1 minus x2 y2. We have to check with this basis, but that is going to be very difficult. And the second thing is that if you want to check with the graph, so this is going to be a paraboloid thing. If you see that, with you, we have the first definition, if you remember, of that convex function. What is that? The upper part, this portion, should be a convex set. And if you check, this is going to be a kind of paraboloid. If you check the shape, this is going to be like this. So by this way, we can say that set is going to be a convex. So this set is a convex set. So that's why this function is going to be a convex function.
So I only imagined this shape and answered.
Yeah. So this is one good. This one is good. Even if you check, this is a negative. So this is also, but not a parabola, downside cap. So this, last time discussed, this is a kind of concave, not a convex. And this one is also this one is going to be a different say. We can check with GeoGebra. Please try to practice the GeoGebra thing.
Sir, convex means it could be positive semi-definite also, right?
Positive semi-definite. I'm not sure about this. So as here, this one convex is that concave is always will get this kind of. Even if it is this kind of shape, then surely some MLF algorithm will be there. But I'm not sure if convex. If a function is concave, in that case we'll get the local minima is going to be global. So local maxima is going to be global maxima. But I'm not sure about that, how it could be used in machine learning. And I don't know, this tells you a surety that positive definite for the convex, but concave I have to check. I'm not sure.
Okay.
Let's do this problem. The minimum value of the function subject to constraint this. What is going to be the minimum value of the function? So answer is going to be 1 by 6 or 1 by 3, Monraj.
1 by 3. 1 by 3.
1 by 3. 2, 3 by. Okay, let's see that. So here we will use now, Lagrange's multiplier method. So we have some objective function and some constraints is here. So what is the Lagrange's multiplier? Gradient of f. So it equal to lambda time gradient of g.
Sir, we have to use minus lambda or lambda?
So here again I will say lambda will manage that, right? Because if this one is equal to sign, then lambda could be anything, right? So that's why better to write just lambda. Will not write minus because of lambda will manage that. Lambda is going to be for equal sign. It is going to be anything, negative, positive, anything.
Sir, if it is not equal to, then something greater
Then
than.
if it is less than or equal to, then it is going to be always positive.
So it means you have to write minus lambda, right?
So in that case, it is going to be minus lambda and this is going to be positive. If it is less than or equal to,
then
See, the formula is minus lambda, but if it is equal to, the lambda can be both positive and negative.
yes.
So it is better we always use minus lambda formula, or how is the approach?
Better to always do either the best way is this one. Generally, we used to do like this one. So anyone you can assume. Either if you are assuming minus lambda, you can go with that. That is not problem. So generally, we used to do like this. The Lagrange equation that is called Lagrange's multiplier equation also. This one. Either by this one is Lagrange's multiplier. Yeah, this one is also same equation.
Right.
So gradient is going to be here 2x, 2y, and 2z. Gradient of, so here we can write like this, or in the column wise, or however, if row wise, if you are writing in the vector form. So let's write in the like this. So 2x, 2y, 2z, and this is equal to lambda time gradient of g. So if we are assuming this is g here, this one is g. So we can send both side whatever the way, like g is sending like this. G is nothing but x plus y plus z minus 1, like this you can assume. And now gradient of this is going to be 1, 1, 1. And as this equation we have, so this is going to be 2x is equal to lambda. This implies x is equal to lambda by 2. Similarly, y is equal to lambda by 2. Z is equal to lambda by 2 from this equation. Now we have some values of lambda here. Okay, so now what is going to be the next step? How we can solve this now? Or what we will use? How we can use this value of x, y, z somewhere?
We put this in the constraint equation.
In the constraints. So that as we have lambda is, we are multiplier here, we are going to use it. So similarly, this constant will give, put in the constant will give lambda value. So here is lambda by 2 plus lambda by 2 plus lambda by 2 is equal to 1. This means lambda equal to 2 by 3, I think. Right? Yes. 3 lambda by 2 and lambda is equal to 2 by 3. Now that means x is equal to
1 by 3.
1 by 3. Similarly, y equal to 1 by 3 and z equal to 1 by 3. Now if we got the values of x. So as the function, minimum value, and we have only one. So just substituting here, so this is going to be 1 by 9 plus 1 by 9 plus 1 by 9 which is 3 by 9, which is 1 by 3. So minimum value is going to be 1 by 3, which is 0.333. Somebody is given that. Okay.
So is it necessary to find other points also?
Other points. So there is, we are not getting other point, right?
Yes, sir.
Suppose some lambda value, we are getting some 2 values, we are getting lambda. So in that case, we have to check that.
Okay.
And which one is going to be give the minimum? We have to compare that with the, the constraints.
Okay.
Okay. Let's do the next problem.
Sir,
Yes.
excuse me, sir.
Yes. Yes.
Sir, if in the previous question we have to find the maximum value, should we follow the same method?
No, so we'll not going to follow the same method. So here it is going to be a problem, and as you can see, this is a paraboloid, or of say of this one, hyperboloid. I don't know what is the we call. If you see that, if it is only these two, if you remove this z square, so it will be of
No, sir, just
this.
I'm asking if a maximum value is.
So in the case of maximum value, for if the problem is of the maximum value, so surely multiplier, and if we use this multiplier, we'll try to solve. But here in the case of maximum value, this function don't have any maximum value. It have infinitely many. If you say some
So
value
when
is,
we find the value of lambda, two different values of lambda, then we find the minimum and maximum.
yes. So in that case, so see, as in critical points of function of one variable, extremum point means critical point either could be maximum or minimum. So suppose you have a function, okay, with some constant. Suppose you got two values of lambda, okay. Suppose we got two values of lambda. So we'll get two values of x, y, and z. So we want to choose the minimum value. So you can compare that, and we will say this, which one is minimum, that is going to be minimum one, and which one is going to be maximum one, we'll say that this is going to be the maximum value of the function. As for the critical point. As for the critical points, we'll check there is some second derivative test, but here whatever the values you will get here, x, y, z, with some, this tells you with some constant you are getting the extremum, either it could be maximum or minimum. So but here only the minimum value is possible for this function, so that's why you are getting only the minimum value of the function. But if the function asks for the maximum value, so whatever the values you will get for the x, y, and two values, let's say 1, 2, 3, 2, some values you'll get. One will help you to find the maximum, one will help you to find the minimum one.
Sir, here there will be on maximum also, no?
One is this is not going to be maximum one.
No, this is not maximum, but there can be a maximum value also, right? But we cannot find it.
This problem, there is a problem with this one, that we cannot find the maximum with this constraint. If you try to for this one maximum, then maximum is in that case
because the delta approach we cannot do, right? Because it cannot be.
yes,
There will be a maximum, but we cannot find using this approach.
this one is not going to help for the extremum, maximum value of the function. If it is if this constraint is not in that case, the derivative test is there, Hessian matrix for the third variable for any case. if you did the maths too, if constraints is not given, in that case, you'll find the Hessian, and using the Hessian, we'll get the extreme maximum, minimum, or we'll decide that which either it could be saddle point, or it could be maximum, or it could be minimum. This is one part. But with the constraint here, even with the constraint, if you are not even, if you assume this is, if you remove this one, then the graph is going to be like this, and plane x plus y, if you remove this one also, x plus y is going to be 1 here. And sorry, here the plane, let's assume this is the plane x plus y plus z. So it will cut like this. On that plane, we want to find the maximum one. Not sure how we'll find that. It will be difficult. More analytic conditions, as you know, for the first variable, if it is the saddle point, or if it is the second derivative test is 0, then we have to do more analysis and more algebraic. So many things are there we have to do, or we can change with the, x, we can change with this, or z is equal to, we'll write like this. Okay, something we have to do with the different 1 minus x minus y, and now we'll substitute in this function. So this function is going to be only of two variable. This is x square plus y square plus 1 minus x minus y. This will be of two variable case, and now we will use the Hessian method. Still that would work, right? Because we are on the constraint. So by this way, we'll use, derivative test, find the critical point, and then Hessian matrix, and using that, or this one fx square. What is that? What is that to test? F of x y, or what is that? F of x, f of y. Some formula is there, right? I don't know what is that exact formula. Either with the Hessian. Okay. If you find the Hessian that this should be positive and the whole determinant should be positive, then you'll get the local minima. And if it is,
so this function will have a maximum value only because of the constraint, right? Yes. Otherwise, this function does not have a local maximum or local global maximum.
No, local minima it will have, but not local maxima.
So
local
minima is going to be use the derivative.
If you remove this constraint, then minima is going to be 0. X is equal to y is equal to z. If you substitute all are 0, then in that case, this is going to be 0. If you remove this constraint. But there is no maxima for this one.
Okay.
So we have to do some with the different method. This Lagrange's is not going to help.
Right.
But this method will work. We'll try to change. But still, if you have the more variable, then it is going to be, we'll get a trouble. If we assume z is equal to 1 minus x minus y, we'll change to put in the function objective function in place of z, and then we'll get a function of two variable, and now we'll do the second derivative test, Hessian method, to get the local maxima and local minima. But if we have more variable, then we are going to be in trouble. Let's do the 8th problem. What is the boundary value of y so that the function is going to be remain convex? So without, there are two methods again. Without going to be, that Hessian. Just looking, while looking, can we answer this problem? We can use the graph. Hessian will work, that's fine. Always will work here. But without the Hessian,
So it's like we are squaring, so anyway it's going to be positive.
sorry?
We are squaring, both the terms are squaring.
Yes.
So for any value it should work.
Yeah, for any value it will work. So shape is going to be, of a parabola kind of. So again, the upper part is going to be a convex set. So that's why this function is going to be a convex function. So there is no constant. If you substitute any value of x, still it will give the shape will be of this one. This some shifted here. There is a shift, but it will be a kind of parabola. So this part is always going to be a convex set. So or we can find this one Hessian. We find we'll get the same method is there whatever we last time did. We'll get on diagonal some positive one and both are going to be 0 of diagonal thing. So there is for any value of x, this function remain convex.
Sir, here for any value of y.
Sorry, for any value of y. Sorry, we want to find the boundary on y. So any value of y, the function remain convex. For any value of x also, the function remain convex.
So just sir, by looking that we can.
Yes.
So no need of any calculation.
Yeah, we no need to do any calculation. The last one is,
Excuse me, sir.
sorry, yes.
Sir, I didn't understand. I understood that for any value of x or y, the function is going to remain convex. But what if some other kind of function is given? Then how should we find?
So if we change, suppose some different function like x square minus is there minus 2xy plus y square plus no plus or maybe let's say plus 5. This function is given, then we have to go with Hessian because we are unable to draw even also, and I don't know what is going to be happen. It could be of this shape. So in that case, we have to check that it is going to be convex or not. So we have to find the second derivative. So double prime here is f, sorry, not prime, which is f suffix x is going to be 2x minus 2y. Yes. And now double derivative with respect to x is going to be
Two.
Minus 2x. Oh, okay. Sorry.
And sorry, double derivative with respect to x and double derivative with respect to x, and then y is going to be
0.
no, this
No,
one
minus 2.
Minus 2.
minus 2.
Minus.
And then double derivative with respect to y is going to be from here 2y 2. We'll get 2 again.
No,
So now
sir. 2 minus 2xy also, no? So it's
minus 2xy will come, but
okay.
but in that case, that's if you do the second derivative, that becomes 0. So only 2 will get. I'm just quickly writing here. So now the double derivative. So Hessian matrix is going to be 2 and then minus 2. So again, so whenever you are doing, some polynomial is given, no? So this is going to be either you will write like this, yx or xy. It is a commutative, okay, a differentiable. So this function is a polynomial. This function is smooth, infinitely many times differentiable. So the partial derivative actually will be a commutative, either is with respect to xy or yx. Whatever the order will not matter here. So that's why it is going to be -2. Means symmetricity will happen. Okay. If the polynomial, this will be a polynomial, then Hessian is going to be a symmetric. And here is 2.
So it shows saddle point.
So now what is going to be, this one is positive, and what is the determinant of this? This is 4 plus 4.
4 minus 4.
Sorry, -4. -4, which is 0. So this is going to be a saddle, right? So
Yes,
even so not saddle mean it is not a positive definite. So not a convex function. For the multivariable function, we'll follow with this method. Hessian is the best one. Now next is this problem. This again the Hessian matrix is given. We just need to check which one is the positive definite. Ninth problem. Ninth problem is, you can leave that ninth problem. 3 times we are discussing. Either just choose which one is going to be the correct option.
Sir, B and D.
B and D. What about A?
Not sir.
Is,
Because it is -5.
-5 is not. It is.
Yeah, this one is. So Hessian is, this should be positive and determinant. So determinant is positive, but the first one is negative. This is going to be 5, and this is going to be 15 minus 1 and 14, which is positive. This is negative here, again not. And this is 5 positive. This is 15 and -4.
Again
Is
positive.
positive. So these two, B and D, is going to be the convex function. Tells the convex function. The convex function. That's all for the today's Solve with Us. Anyone have any kind of doubt?
So that first question you said we will. I think.
Okay, this one. Oh, sorry. Yeah, yes, forgot that. This one. Where is that?
Second question.
So we got this one. 2 lambda plus 3. So let's do on quickly on GeoGebra. We can visualize very quickly.
Okay.
That what is going to be solution is going to be unique or not, no solution or infinitely many solutions. So first one is x. There are 4 variable, no? So it will not. We are not going to deal with, Okay, sorry. There are 4 variables. So let's solve this. So this is we have. So this is 2 lambda 3 plus 2 lambda 4 equal to 3. 2 lambda 2 plus 2 lambda 3 equal to 1. Sorry, what is that 1? 1. And lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 equal to 1. So system that, Gauss elimination will work here. So just a second. So This is 2, 2 everywhere, right? 2, 2, 2. Okay. So here is 0, 0. Let me increase one variable. 2 is there, and 4 in fourth of place 2 is there. 3 and 4. 2 and 3 is 2, 2. Where is that? This is 2 and this is 2. And rest all are here is, I think, what is that? 3. This is 1. And the last one is 1, 1 is each place.
It is equal to 1.
Sir, we
That
write
is equal
it
to 1, right?
sir, 1, sir.
Is that one? Oh, yeah, this one is 1.
Nice.
System has a solution which is of this form: x1 plus x4. x4 is everywhere is independent. We have independency here, and this is in. So here it have infinitely many solution. So means lambda 4 have, we can assume lambda 4 as independent, and we can write x1, x2, and x3 in the form of x4. So again, here we are not getting a constant, right? X4 is going to be anything, means lambda 4 is going to be anything, still that you will get always a solution. So for lambda 1, lambda 2, and lambda 3, we'll follow that, but we need a constraint at least for any real value of x. So I don't know, just a second.
So maybe we can use 1, 1 instead of 3, 1.
3, 1.
We used 3, 1. Instead of that, if you use 1, 1, you see what happens.
So 1, 1 is going to be in the convex hull, right?
Correct. So whether we are getting some, how is the system of equation?
Still in that case, we'll get infinitely many solution again, but with the constraints are okay. x1 plus x2 plus. So here is x1 plus, if you add here x1 plus x2 plus x3 plus x4, here is going to be 1, but at 3 here. So again, just a second. So for 3 here, it is not going to be 1. If you add all 4 equation, what we'll get here? x1 plus x2 plus x3.
This is minus 1, sir. So you will get 1.
This is minus 1. This is 2 and 1. Again, we are getting 1. So what is going to be in that case? Hmm. Three, 1. 2, 2, 2, 2, 1, 1, 1, 1. That's fine. This is.
Sir, that 1 is not known, right?
Sorry, 1?
Lambda 1, lambda, the third equation. How do we assume lambda 1, lambda 2 is 1, 1, 1, 1?
So here it is a coefficient, no? This one is the coefficient. Lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 equal to 1.
Correct. But lambda 1 is not equal to 1, right?
Lambda 1 is not going to be 1. So here we are not getting also 1. We have 3 equation. We are just writing in system of linear equation. Here we have, and then we are finding that this is 2x1. This is the constraint here. x1 plus x2 plus x3 plus x4 is equal to 1.
No, our equation is okay. Okay. Right. Okay.
This is fine. There is no issue with the equation.
Okay. Sorry.
Something some contradiction will get here from this solution. What is the contradiction? Okay, for 1, what we are getting, the same thing we are getting with 0 point, and here again infinitely many solution. The second constraint is that all should be positive. X1 plus X4, X2 minus X4, X3. So here if you add, this will get -1 is there, so we'll get 1. That's fine. And
So the
the
second equation says 1 is not positive, is it? X2 minus X4 equal to -1 means
the second equation is X2 minus X4.
is
So here
minus.
we have all are positive. That means, and okay, there is one constraint is that, okay, so X2 and X4, but even it could be manageable. 1 plus sorry,
So
X1
it is 0 and 1. If X2 is 0 and X4 is 1, then we get -1.
yes, 0 and 1, but still the case is that X1 and X4 sorry X3 should be positive. Okay, from here something will get X2 plus X4 is equal to 0.5, X2 minus X4 is equal to -1, and sorry, yes, this is X1, this is X2 minus X4, X3 plus X4 is equal to 0.5. So this one is,
It is 1.5, sir. Third one.
sorry,
1.5, I think. The third one. X3 plus X4 is 1.5.
1.5. Okay, here is also 1.5. From these two, we are getting X2 plus X3 is equal to 0.5. X2 plus X3 is 0.5. And X3 plus X4 is equal to 1.5. It will be difficult now. It will be difficult.
So for such questions, it's like we should just plot. If it's easy
For
to
this problem, plotting is one thing, but
But
this
plotting is okay only if it is a two-dimensional vector. If it is more than three-dimensional, we don't have a plotting option, right? We should have a
that is true.
method.
lambda is positive greater or equal. If you have 4 equation, then we are done. But 4 equation, we don't have 4 equation, only 3 equation we have. Okay. So x1 is going to be 0.5 minus x4, I mean to say 1/2 minus x4. x2 is 1 plus x4. x3 is 3/2 minus x4. x4 is anything. So if we assume here x4 is anything, if we assume x4 is equal to 1. So one thing we can notice that if we assume even if we assume x4 is equal to, I think we have to check with some number. And for the 1 case, it will satisfy for anything, I think. But for this one, it should be some wrongness. So if we assume x4 is equal to 1, this is 1/2, so negative we are getting. For the case of if we see it for this one, for 1 case, we are getting what is we are getting here. If it is 1 if it is 1
1 becomes 0. X2 minus x4 is 0.
Okay, so
And
here
x2 plus x4 is 0.5.
x2 plus x1 plus 0.5, x2 is equal to x4, x3 plus x4 is equal to 0.5.
Yeah.
So if you assume here for the case of 1, x4 is equal to 1, then x2 is equal to 1. And then 1 plus 1 is going to be 1 plus 1. Already 2 is there. Okay. But that should be less than or equal. Sorry, equal to 1. We have to check. This time I'm not getting a different method.
Okay.
If it is in the higher dimension, still there is this. Okay. Maybe probably in the next session I will try to solve with the different. I will come with the different approach. Okay.
Right. Yeah.
Thanks everyone.
Yeah. Thank you.
The next session I will get a different. Surely I will get a different approach. Thanks.
Thank you.
Thank you, sir.
Thank you, sir.
Thanks, everyone.
Thank you, sir.
Thank you, sir.